Let's learn now how to prepare nitriles and what are the main reactions of nitriles. And at the end of the video we are going to see 3 examples of multi-step synthesis that include knowledge of nitriles, carboxylic acids and some previous knowledge. Let's start first with preparation of nitriles. We can prepare nitriles from primary or secondary alkyl halides through SN2 mechanism. Like in this case we have a primary halide, treat that with sodium cyanide and you're going to get a nitrile. Right? The second way to prepare nitriles is from dehydration of primary amides. Amide group is a group that contains carbonyl compound and also amine group, together connected. So we can use thionyl chloride in this case and to get the nitriles. Right? Let's move further. Now, the reaction of nitriles. Conversion of nitriles into carboxylic acids by hydrolysis. So, you can treat a nitrile with H3O+, or in acidic medium or in basic medium. First stage is you are going to get an amide, and after that, after a second hydrolysis, you are going to get the carboxylic acid. So, in both cases, you are going to have the same compound. Right? Let's move further. Conversion of nitriles into amines by reduction. So in this case, what you're going to have the formation of an amine. So primary amine. Right? With lithium aluminum hydride in ether, and after that at the second stage with protonation by water. Formation of ketones from Grignard reagent. If you react a nitrile with a Grignard reagent, you're going to form a ketone at this carbon here. So, what you're going to form? A ketone. Right? Those are the main reaction of nitriles. Let's move to the first example. So, from this compound to prepare this compound. As you can see, the first thing that I notice is that you have addition of carbons, and this is an alkyl halide and this is a carboxylic acid. I made a specific video that suggested that you have to go backwards, not like forward, because it's simple, but it's up to you. So from carboxylic acid we can go back to convert that to a nitrile. And to convert a nitrile to carboxylic acid was easy, just by hydrolysis. Right? And to form a nitrile is simple from alkyl halides. What we did? We reacted that with sodium cyanide according to SN2 mechanism. Right? Because this is a primary halide, this is a primary halide and it works best through SN2 mechanism to prepare the nitrile. Do we have other way to go here? Yes, if you're in exam, just figure out a way to go to the product if it's not specified. So in this case, what you can do? You can form Grignard reagent with magnesium in ether, and after that you can do carboxylation, and after that you can do hydrolysis. Right? And again you're going to end to this product. Let's move to the second example. From point E to B, C, D, E, F. What are the reagents that you need to react those compounds to go to the next step? Now, let's start now. If you have in this case, you do not need to go reverse. Go from the first, second, third, and so on. So, from a double bond to yield a non-Markovnikov alcohol, what we use? We use BH3, DHF, solvent tetrahydrofuran, and the second stage was H2O2 OH-. Now, from primary alcohol to an alkyl halide, what we did? We use phosphorus 3-bromide in ether. Right? And after that, from alkyl halides, we went to the carboxylic acids. What we do that? Here we have the option to use nitriles or to use carboxylation. Let's use nitriles. It's simple because it's primary halide. So what you're going to do first, and the second step is by hydrolysis. right? Let's move further now from carboxylic acids to primary alcohols. What is done? A reduction. So we learned that lithium aluminium hydride. Second stage, H3O+. Now from primary alcohols to aldehydes. So what we did, a weak oxidizing agent, desmartine periodion in dichloromethane. And from aldehydes, we removed the aldehydic group. We used, as if you remember, hydrazine in potassium hydroxide. And that's it, done. Okay, let's move to the third example. Now, we have a bulky carboxylic acid here, and here we notice that it's not possible to use nitriles. So you have to use carboxylase for sure in this case to form carboxylic acids. So the previous compound should be halogen, Br, for example. And here you can form Grignard reagent, second stage carboxylation, and the third stage is going to be hydrolysis. Right? Let's add those double bonds here. Now let's move back. Now to add this bromine here, if you remember from alkenes, the allylic bromination by NBS in benzoyl peroxide. Okay, so now from here and from here to go here, you should know for sure that is Friedel-Crafts reaction. It's an alkylation. So CH3, CH chlorine, CH3 in what? What was the catalyst? Aluminium 3-chloride. So this react with this one to give this one, from this one to go to this one to this one. And that's it. Let's move to the last example. Now this is phenyl, in case you don't know. This is phenyl. And again a carboxylic acid here that is in a bulky substituted position. So the first stage here should be what? The removal of the carboxylic acid. So phenyl remain untouched, and here should have been a bromine, for example. So what you are going to do here to yield the carboxylic acid, first magnesium in ether, second is carboxylation, and the third is hydrolysis. Right? Let's move back. Now we want to go to that ketone. So what has happened here? You know that when ketones react with Grignard reagent, they yield tertiary alcohols. So we need to yield this tertiary alcohol, right? And now from this ketone to go here, what we need to do? To add this reagent, the phenyl group, that is with magnesium, bromine in ether, the first and the second is hydrolysis. And that's it. Done. We can prepare tertiary alcohol, halide, and go to our final product. Thank you so much for watching, and look forward to see you to the next video that is related with carboxylic acid derivatives. Up until there,